Now you can start. Make sure before start coding, reset the timer, and then you need to go through the question. And then if you have any question, just let me know. I will give you hint. And then you have 40 minutes to complete this question. And then you need to explain the idea first, and then you can start coding up. Finally, you should tell me the time capacity you used. Yeah, you can start it now.
Okay, today we're going to solve a very early LeetCode question called container with the most water. So we're given an integer array of length n, which has various heights. So as you can see here, the first bar is of height 1, the second bar is of height 8, next one 6, and so on and so forth. So each of the values are each of the heights. So you have n different vertical lines drawn such that the endpoints of the ith line are at I0 and I of height of I. So n vertical lines obviously is the length of the array because we have each height is each element in the input array. And we want to find the two lines together that form a rectangle such that this rectangle contains the most water when you multiply the height by the width, except with one little trade-off. Because you have to use the smaller of the two heights as the vertical dimension. So as you can see here, the max area we can get cannot be 56, it's 49 because 7 times 7 is 49. Because out of these two, if we want to use them, the shorter height is the restriction. And the other thing is that you cannot slant the containers, so you can't go here and try to calculate this height. You can't go here and try to calculate this height, although that would be a little bit more than what you're getting here, probably about, let's say, 49 plus 56 divided by 2 plus, so that's about like 52-ish. You can't do that. And notice that the input array is not sorted. And we're given two examples here. And yeah, so we want to find the maximum amount of water the container can store. And this is a two-pointer question where we will start at the beginning of the array with the left pointer and the end of the array with the right pointer. And the area, as mentioned, is the width times the height. So it's going to be right minus left times minimum of height of left, height of right, because again, we have that restriction. So this is going to be the vertical diagonal. This is going to be the width. This is going to be the height. And so we'll compute that here. For example, 7 minus 1 is 6. 6 times minimum is 1 equals to 6 because we can't use 7 here. That would be great if we could, but we can't. And then now we will move the pointer that has a lower value towards the center. So left, right. Again, we get, looks like 7 times 7 because 1, 2, 3, 4, 5, 6, 7 in terms of indexes. So right minus left times minimum of height of left, height of right, because 8 is smaller, 8 is bigger than 7, so we have to choose 7. 7 times 7 is 49, which happens to be a result. But let's say that we didn't find a result. Again, we would move right down this time because 7 is smaller than 8. So we would get right at 3. And we would keep doing this until we get to the center, until right and left cross, because we don't want to waste time when we come back around. So for example, if right and left are right here, we don't want to keep going because this would be wasting time. We already calculated that when we came in the first term, because right and left are restricted by the minimum of both of them. So the values will be interchanged between left and right, meaning that 2 and 4 will already have been calculated as having the maximum width, the maximum amount of water we can store at that point. And so, yeah, this is, again, a pretty straightforward two-pointer problem, and the array is not sorted, so that's why we have to use this approach, or else we could use a binary search. If the array was sorted, this would be pretty easy. We would take, obviously, the biggest width we could get, and then, you know, the second biggest height, but obviously that's completely different from what this question asks. So hope that's clear. I'm going to start coding this up, and the time complexity is O of n, because we are technically looping through the array once with the 2 pointers until left and right pointers meet in the center. And this is important. We want left and right to meet in the center once, or else we could potentially miss one biggest calculation.
Okay. You can start it now.
So as said, we're going to define our left and right pointers. While left is less than right, less than or equal to right, as mentioned, we are going to calculate the area, which is the width times the smaller of the two heights. And let's make a result variable. And we've calculated a new area, which is guaranteed to be bigger than 0 as long as the array, well, chances are it is bigger than 0 if the array has more than one element. So we're going to update our result with the max of area. And every time we have an area computed, we want to move the pointers downwards, because at that particular point, we have calculated the maximum we can get. Because the width is always obviously very straightforward, but the height has already been calculated. So let's say that height of left is less than height of right. Then we're going to move left inwards. In any other case, we're going to move right down. If they're equal to, we can choose either pointer, because neither pointer is constraining the finding of the maximum area more than the other in that case. So we're going to keep doing this until, again, we reach the center, then we will have our answer, and that will just be result. So let's run this.
Ooh,
And as you can
okay.
see, it should pass all the test cases. And there you go.
Okay.
I
So
think I got a slightly better time complexity the other time compared to this time. So this number, you can't really trust it.
okay.
If you run it a bunch of times, you'll get a bunch of different numbers.
But
But the more people that do this question, the worse your runtime seems to get, because see, 51%. So take these numbers with a grain of salt.
okay, thank you. I think you do great. Great.